Welcome to S1 Lesson 12, Continuous Random Variables, Mean, Variance, Median and Quartiles. So before you start the video, if you have access to the presentation slides, it's a good idea to have a printout of it so you can record on there any notes that you want to make, any thoughts, any feelings, important things to remember. If you don't have access to the presentation, that's fine. What I'd recommend is that you just have a pen, paper and calculator ready anyway, because parts of the video you can pause and have a go at some of the examples and then mark yourself afterwards. So today's lesson is concluding the S1 module in total. We've covered probability, discrete random variables, binomial and Poisson distributions. The final module part of the module is continuous random variables, and we're on the second lesson, which is covering the final content for continuous random variables. So we're finishing off S1 today. So looking at the continuous random variable mean and variance, if we have a continuous random variable x and it has a probability density function f of x, then the mean can be calculated by integrating x multiplied by f of x dx between the bounds of the range that the PDF is valid for. If you want to find expectation of x squared, very similar to the expectation of x, the mean. Remember that this is equal to the expectation of x. Very, very similar. Only difference is instead of multiplying by x, we multiply the function by x squared. And again, we integrate between the bounds of the function for which it's valid. Finally, the variance of x is calculated in exactly the same way that we calculated the variance of x for discrete random variables. It's the expectation of x squared minus the mean squared. Let's look at an example then. A continuous random variable x has a probability density function given by f of x is equal to 6x times 1 minus x, valid between 0 and 1. And all other probabilities, all other values are 0 otherwise. So we're looking to find the mean and we're looking to find the variance. So remember that the mean is defined as the integral between the bounds for which the probability density function is valid, so in between 0 and 1, x times the function of x. So x times 6x 1 minus x. And we're going to integrate that with respect to x. So the first thing to do is expand this out and multiply by the x so that I've got an expression which I can actually integrate. So x times 6x is 6x squared. So we're going to multiply 6x squared by 1, gives me 6x squared. I'm going to multiply 6x squared by minus x, that gives me minus 6x cubed dx. So now we've got a polynomial. I can integrate my polynomial. So square brackets because I'm doing definite integration. 6x squared will integrate to x cubed. 6 divided by 3 will give me 2. Minus x cubed will integrate to x to the power of 4. 6 divided by 4 can cancel to 3 divided by 2. And we're integrating this between 0 and 1. If you need to take a couple of steps so that you can simplify this, that's fine. I'm just saving a little bit of space and time. Okay, so now we're going to evaluate the integral between the bounds. So we're going to put 2 times 1 cubed minus 3 over 2 times 1 to the power of 4. Minus, and remember, although this will evaluate to 0 when we substitute the 0 in, not all functions evaluate to 0, so it's good practice just to put it in anyway. So we get 3 over 2 times 0 to the power of 4 equals. So show the substitution, show that you can integrate correctly, and type this into your calculator all in one go. If you evaluate this all in one go on your calculator, you should get a value of a half. So the mean, or the expectation of x, is equal to the mean, is equal to a half. Okay, so next we need to find the variance. To find the variance, I need to know the expectation of x squared. So if we make it clear in my working that this is the expectation of x, let's do the expectation of x squared. This is an identical process, except in the initial step, I multiply the function by x squared, rather than multiplying by x. Now, this can be fairly simply done just by comparing to our last expression. Each of the powers of x are going to be at 1 higher, so I'm going to have 6x to the power 3 minus 6x to the power 4 instead. So when I integrate, I'm going to raise the power of x cubed to x to the power 4. I'm going to divide 6 by 4, and so I get 3 over 2. Minus, I'm going to raise the power of x to 5, and then 6 divided by 5 can't be simplified any further, so I'm going to leave it as 6 over 5. Integrating between 0 and 1. So now substituting our values, so I get 3 over 2, x to the power 4. Sorry, I should be doing 1 to the power 4, little lapse of concentration there. Let's tidy that up. So 3 over 2, 1 to the power of 4, minus 6 over 5, 1 to the power of 5, minus 3 over 2, 0 to the power of 4, minus 6 over 5, 0 to the power of 5, equals. So, type this into your calculator and work through it. Make sure you're careful when you type it all in. If you do that, you should come out with a value of 3/10. So the expectation of x squared is 3/10. Okay, so all that leaves now at this point in time is to find a variance. The variance is defined as the expectation of x squared minus the mean squared. So this is going to be 3 over 10 minus the mean, which is a half, squared. Type this into our calculator and you will get a value of 1 over 20. Okay, well I hope that all made sense to you, because it's going to be time for you to try one now. So we have a continuous random variable x. It's got a probability density function defined as f of x is equal to x squared over 21 when x lies between 1 and 4, 0 otherwise. And just like the last example, I want you to find the mean and the variance. So at this point, pause the video, have a go at it yourself, and then resume when you're ready to check over the answer. Okay, so let's have a look at the answer then. First of all, let's find the mean, the expectation of x. This is defined as integrating between 1 and 4, x times our function of x, so x times x squared over 21, dx. So what's going to happen here is we are going to get the integral between 1 and 4, x cubed over 21. Now sometimes I like to take the constant outside the front and deal with that last of all, but when it's a single term there's no real advantage to that, so I'm going to leave it in as it is at the moment. So when I integrate x cubed, it raises to the power of x to the power of 4, and so then when I divide by 4 I'm going to multiply the denominator by 4, so I get x to the power of 4 over 84. And I'm going to integrate this between 1 and 4. So now let's evaluate the integral. Substituting in the 4, I get 4 to the power of 4 over 84 minus 1 to the power of 4 over 84. So I just type that carefully into my calculator and you should get an answer of 85 over 28. Which isn't a particularly nice decimal, so I'm just going to leave it as it is. Next, let's find the expectation of x squared. So let's just state that, so just as nice and clear for us. So the expectation of x is equal to the mean, which is equal to 85 over 28. So let's do this for expectation of x squared. Exactly the same process, remember, except we're going to multiply the function by x squared instead. So we'll get x squared times x squared over 21 dx. So this is going to come out as exactly the same as before, except the power is going to be 1 higher, so x to the power of 4 over 21, And so when I integrate this, I'm going to get a power that's 1 higher, so it's x to the power of 5. And I'm going to multiply the denominator by 5, so I get x to the power of 5 over 105, integrating between 1 and 4. So let's evaluate the integral. We have 4 to the power of 5 over 105 minus 1 to the power of 5 over 105. And so when you type this into your calculator carefully and work through it, you should get an answer of 341 over 35. Okay, so that was expectation of x squared. So all that's left to find now is the variance. So let's just state that explicitly for me a second. So 35, great. So then the variance, we know that this is the expectation of x squared minus the mean squared. So we get 341 over 35 minus 85 over 28 squared. If you type this in on your calculator, it doesn't come out as a fraction, it just comes out decimal, so we get 0.527 correct to 3 decimal places. Okay, well I hope that all made sense, and more importantly that you had a go and you got the right answer. So now we're going to look at finding medians and quartiles. So the median m of a continuous random variable is the value for which the probability x is less than or equal to m is equal to 0.5. And the probability of x being greater than or equal to m is also 0.5. It is the value that is going to be right in the middle of the distribution. So to find the median, what we need to do is we need to solve and find when will the probability of x less than or equal to m be equal to 0.5. And to do that, we use the cumulative distribution function. We can also use a similar idea to find the kth percentile. So if we want to find a 10th percentile, a 35th percentile, or particular percentiles like the lower quartile and the upper quartile, which are the 25th and 75th percentile. In order to do this, it's a similar idea to the median. Remember that the median is the 50th percentile. So what we were saying for the median was f of m is equal to 0.5, which of course, if the median is the 50th percentile, is 50 over 100. So actually this is the same idea for the median. It's just that the median is a very specific value, just like the lower quartile and the upper quartile. So let's have a look at an example. We have a continuous random variable x. It has a probability density function given by f of x is equal to 4x times 1 minus x squared, which is valid between 0 and 1, and the function is 0 otherwise. So we're going to find, first of all, the cumulative distribution function, because I need that to find the median and the lower quartile, and then I'm going to find the median and the lower quartile. So starting off, if you remember, f of x is defined and found by integrating our function written in terms of t, and we integrate between the lower bound, which is 0, and x, which will help us create a function. So instead of writing this as 4x times 1 minus x squared, we're going to write this as 4t times 1, which is 1, minus 4t times t squared, which is 4t cubed. And we integrate this with respect to t. So integrating t gives us t squared. 4 divided by 2 gives me 2t squared. Minus integrating t cubed gives me t to the power of 4. Divide 4 by 4, I get a coefficient of 1. And I'm going to evaluate this between 0 and x. So when we evaluate this between 0 and x, I get 2x squared minus x to the power of 4 minus 2 lots of 0 squared minus 0 to the power of 4. So we get left with the function 2x squared minus x to the power of 4. So this is our f of x now. our cumulative distribution function. So it's equal to 2x squared minus x to the power 4. Now, if I want to find the median I'm saying I want to solve f of m equal to 0.5 because it's the 50th percentile. So in other words, we set up this equation 2m squared, so I'm substituting m into my cumulative distribution function here, minus m to the power of 4 is equal to 0.5. Okay, so I'm just going to rearrange this equation so that I have the m to the 4 and a 2m squared all on the same side. So I'm going to add m to the power of 4 to both sides. And I'm going to subtract 2m squared for both sides. And this leads me to the equation m to the power of 4 minus 2m squared plus 0.5 equals 0. I'm also going to times by 2. And I'll explain this a little bit further in a moment once I've done the steps. So I get 2m to the power of 4 minus 4m squared plus 1 equals 0. Now the reason I've done this is because actually this is a quadratic equation. It may not look like it at first, it may look like a quartic equation. A quartic equation is of course an equation with the highest power is a 4. However, we can consider this as 2m squared minus 4 lots of m squared plus 1 equals 0. So it is a quadratic in m squared. I know that seems a little bit strange, but if you consider, and I'm just going to do it at the top in blue, this is a quadratic. Essentially, if we said m squared equals y, this is a quadratic in 2y squared minus 4y plus 1 is equal to 0. Okay. Now, sometimes people like to use this substitution. I personally prefer to work with a quadratic in m squared. If I try to factorize and solve this to find values for m squared, you'll find that actually this is unfactorizable, because if I do 2 times plus 1, there are no factors of 2 which will sum to give me minus 4. So I'm going to use a quadratic equation to solve this anyway. So what we're going to say is m squared is equal to minus 4 plus or minus the square root of minus 4 squared minus 4 times a, which is 2, times c, which is 1, all over 2 lots of a, which is 2 times 2. Now if you work through this, I'm not going to show any more intermediate stages here. If you work through this carefully on your calculator, you get that m squared is equal to 1.866, or that m squared, sorry, there's a mistake typing in the calculator there, so it's not actually equal to 1.66, it's equal to 1.707. So 1.707, to make it clear that's a 0, and the other value that this is equal to is 0.293, and both of these are to 3 decimal places. Now I've got 2 answers for the median here. You can't have 2 medians, you can only have 1 median. So at this point, we need to really go back to the range. Let's get a red pen to help us highlight this. Here is my range. The median must lie in this range. So all x values lie in this range. So it's just a reminder really that the x values don't actually exist for this function outside of the range 0 to 1. So 1.707, even though it's for m squared, if I take the square root of 1.707, it's still going to be bigger than 1. It's not going to be in our range. So that is not going to be a solution. So what we actually know then in that case, since m has got to lie in the range 0 to 1, m squared must be equal to 0.293. And if we take the square root of that, So obviously I'm taking the square root of the exact value on my calculator. What we get is that m is equal to 0.541 to 3 decimal places. And if you substitute that back, or the exact value back into our equation here for f of x, the cumulative distribution function, you should find it comes out at 0.5. Okay, well I hope that made sense. Let's have a look now. Part B said to find the lower quartile. So we're going to follow exactly the same method as we have done for the median. It's just that the function will be equal to 0.25. So let's go on to a new slide. We had that f of x is equal to 2x squared minus x to the power of 4. So what we're trying to find here, let's say U is for L is for lower quartile. Well, let's just use Q actually. Q equals quartile. Okay, so what we're saying is f of Q is going to be equal to 0.25. So in other words, substituting Q in, we have 2Q squared minus Q to the power of 4 is equal to 0.25. So I'm going to take exactly the same approach as I did a moment ago, and I'm going to form a quadratic in Q squared. So we're going to add the Q to the power of 4 to both sides, and I'm going to subtract 2Q squared from both sides, so that I get Q to the power of 4 minus 2Q squared plus 0.25. In this equation, I'm going to multiply it all by 4 to get rid of the decimal. I mean, you can try and solve it from there. Just find it a little bit neater writing it into the quadratic formula as integers. But also, really, I want to check to see if I can factorize first of all. So I've got 4q to the power of 4 minus 8q squared plus 1 equal to 0. And again, this is that quadratic, as I said, in q squared. So this is going to be 4q squared minus 8q squared plus 1 equal to 0. And again, if you're struggling to see what we're saying about this equation, if I say q squared is equal to y, then I've got here 4y squared minus 8y plus 1 equals 0. Check to see if I can factorize. 4 times 1 is 4. Factors of 4 that add to minus 8 doesn't exist, so I'm going to have to again use the quadratic formula. So we're going to say q squared is equal to minus b, so minus 8, plus or minus the square root of minus 8 squared minus 4 times a, which is 4, times c, which is 1, all over 2a, so 2 lots of 4. If we work through this on a calculator, you'll get two values. One on the calculator will be 1.866, and the other on your calculator will be 0.134. Again, I want to highlight the fact that the range, remember that the range is x must lie between 0 and 1. So our values must lie between 0 and 1, and so the 1.866 is ruled out as a possible value for the quartile. So we get left with q squared must be equal to 0.134. Let's just acknowledge that this was written to 3 decimal places back there. And again, I'm using the exact value here. So if I take the square root and I'm using the value on my calculator, we get that q, the quartile, is 0.366 to 3 dp. So lower quartile is 0.366. Now again, if you use the exact value stored on your calculator and substitute it into f of x, then you will find, hopefully, that it comes out at 0.25. Okay, so I hope you understood that, because now it's time for you to try one out. So we have the continuous random variable x. It has a probability density function given by f of x is equal to x squared over 21, defined between 1 and 4, and equal to 0 otherwise. So you're asked to find the cumulative distribution function, the median, and then the upper quartile. So at this point, pause the video, have a go at it yourself, and then once you've had a go at it yourself, just resume the video and check to see if your answer was correct. Okay then, well, welcome back. Let's have a look at the solution to this problem. We're going to start off first of all by finding our cumulative distribution function. So f of x is given as integral between 0 and x, rewriting our function in terms of t squared over 21, integrated with respect to t. So we get t cubed, raising that power by 1, divide by 3, so we get 21 times 3 as in the numerator, so I get t cubed over 63. We're going to integrate that between 1 and 4, at 1 and x, sorry, force of habit there. So when I integrate this, I get x cubed over 63 minus 1 cubed over 63, which of course is 1 over 63. So this can be simplified to 1 over 63 x cubed minus 1. And so f of x is equal to 1 over 63 x cubed minus 1. So first of all, we want to find the median. So we're going to find f of m equal to 0.5. So again, what we're going to do is say 1 over 63 m cubed minus 1 is equal to 0.5. So if I multiply both sides by 63, let's try and solve this. Let's get the m cubed on its own. If we multiply both sides by 63, we get m cubed minus 1, or half times 63 is going to give us 31.5. And so if I add 1 to both sides, I get m cubed is equal to 32.5. And finally, if we take a cube root of both sides, we get left with m is equal to 3.19 to 2 decimal places. So the median is 3.19. And again, if you put this value, the exact value that you have in your calculator, into the cumulative distribution function, you should find that it evaluates to 0.5, which is our median. Okay, part C said to find the upper quartile, so let's find the upper quartile. We know that f of x is given as 1 over 63 x cubed minus 1. We want to find, let's say, q again equals quartile. It doesn't really matter what value you use, you could just use x, but just trying to separate from when we've got the cumulative distribution function and when we actually got a particular value. So we're saying f of q is equal to 0.75. Okay, so what we're actually saying here is 1 over 63 q cubed minus 1 is equal to 0.75. So same steps really here. We're going to multiply by the 63. So 63 times 0.75 comes out as 47.25. So we're going to have q cubed minus 1 is equal to 47.25. I'm going to add the 1 to both sides. So I get left with q cubed is equal to 48.25. And then finally, just as we did before, I'm just going to cube root both sides. And that leads me to the answer that q is equal to 3.64 to 2 decimal places. So upper quartile is 3.64. Okay, well I hope that example made sense and that you're feeling confident that you can now attempt to find medians and quartiles and percentiles for yourself. Let's finish off today's video just by looking at an exam question, pulling all the skills for continuous random variables together. So this exam question comes from June 2005. We're told the continuous random variable x has a cumulative distribution function given by f of x is equal to 0 for anything less than 0. F of x is equal to 4x cubed minus 3x to the power 4 for x lying between 0 and 1. And f of x is equal to 1 for any values greater than 1. First of all, we're asked to evaluate the probability that x lies between 0.2 and 0.8. So we're trying to find probability x lies between 0.2 and 0.8. So this would be found by doing 0.8 in our cumulative distribution function, take away 0.2, our cumulative distribution function. So let's just find, because it's not a simple function, let's just find f of 0.8 first of all. And what you'll find actually in the mark scheme is that you get marks for demonstrating that you can find these values separately. So I get 4 lots of 0.8 cubed minus 3 lots of 0.8 to the power of 4. When I put that into my calculator and evaluate that, we get an answer of 0.8192 to 4 decimal places. If I do the same for f of 0.2, I get 4 lots of 0.2 cubed minus 3 lots of 0.2 to the power of 4. Type this into a calculator carefully and evaluate it, so I get 0.0272, and again this is for 4 decimal places. So what we get as an answer is 0.8192 minus 0.272. So finally, the probability that x lies between 0.2 and 0.8. We do the final calculation and we get an answer of 0.7920 to 4 decimal places. Okay, that was part A. Let's look back. Part B asks to show that the lower quartile of x lies between 0.45 and 0.46. So be careful of the wording of this question. It's not actually asking you to find the lower quartile. It's asking you to show that it lies between 0.45 and 0.46. The way we can do this is if I evaluate the cumulative distribution function for 0.45 and for 0.46, I should show that 0.25 lies between the two values. So part B, start off by doing f of 0.45. So we're going to have 4 lots of 0.45 cubed minus 3 lots of 0.45 to the power of 4 equal to, well, if we type this into a calculator carefully and just evaluate that, we get a value of 0.241, which of course is just less than 0.25. Let's do the same for f of 0.46 now. So we get 4 times 0.46 cubed minus 3 times 0.46 to the power of 4. Type this into your calculator and evaluate it carefully. We get an answer of 0.255. And so you can see it's slightly more than the lower quartile. So therefore, lower quartile lies between 0.45 and 0.46. Just remember to state what it is that you've actually found. Okay, before we move on and look at parts, we'll go back to the question and look at part C now. So we'll do the marking all at the end. So find an expression for f of x valid between 0 less than or equal to x less than or equal to 1, where f denotes the probability density function of x. So what you should remember from last lesson is the probability density function is equal to the derivative of the cumulative distribution function. So what we're looking to do here is I'm looking to differentiate 4x cubed minus 3x to the power of 4. So this comes out, just differentiating normally, there's nothing unusual about this. I get 12x squared minus 12x cubed. And we're done. That is it. So f of x is equal to 12x squared minus 12x cubed. Okay, so that was part C. Let's finish off the question now by looking at part D. Part D asks us to find the expectation of x. So what we know now, this is the reason why we've got the probability density function. We've been asked to find that because to find the expectation of x, or the mean, is defined as the integral between our bounds, which is 0 and 1, of x multiplied by 12x squared minus 12x cubed. So integrating that with respect to x. Just going to rewrite this. One thing I'm going to do is I'm just going to take the 12 outside of the integral and just multiply it by it last. Integrating between 0 and 1, x times x squared is x cubed, and x times x cubed is x to the power of 4. So integrating that with respect to x. So finally, just finishing off, we get the integral is between 12, it's going to be x to the power of 4 over 4 minus x to the power of 5 over 5. And we're going to evaluate this between 0 and 1. So 12 times 1 to the power of 4 over 4 minus 1 to the power of 5 over 5. Take away 0 to the power of 4. Remember, just be complete. It's good practice because not all functions will evaluate to 0. So 0 to the power of 5 over 5. And close up my brackets. So at this point you've demonstrated all your working because you've expanded to make sure you've got a polynomial that you can integrate. You've shown how to integrate it. You've then shown how to substitute into the expression to evaluate it correctly. So finally, if you work through and type this into your calculator, what we should get is an answer of 0.6. Okay, so let's have a look to see actually how this is marked. So question A, we'll go back part by part. We get a standalone mark for f of 0.8, a standalone mark for f of 0.2, and a standalone mark for our final answer. So you'll see that we have here a standalone mark for f of 8, that's our B1, standalone mark for f of 0.2, so that's B1, and then finally a standalone mark for the probability. Okay, so let's look at part B. Part B, there's marks given for evaluating f of 0.45 and f of 0.46, and then a standalone mark for explaining that the lower quartile lies between 0.45 and 0.46. So remember, there will be a mark for these explanations for stating what it is you found. So here I have one standalone mark, here I have my one standalone mark, and finally this line here, the lower quartile lies between these values, that is one of my standalone marks. Okay, so let's look at part C. Part C, f of x is the derivative of f of x of our function. That's our method mark. We need to somehow state that. And then our answer mark given for our expression, as long as it's an equivalent expression. So if we go back to our question, here, this is my method mark, or we could say this one here, either one, it doesn't matter. And then finally, here is my result, here is my answer mark. Or we could say down here perhaps is my answer mark. Finally, find an expectation of x. So expectation of x. Method mark and answer mark for demonstrating correctly that we are going to multiply the probability density function by x. Then get an answer mark for the expression where I've integrated if I've done it correctly, and then an answer mark for 0.6. So if we just go back to my question, here we have, this is my method mark, and I get an answer mark for using the correct values. Down the bottom here, this is where I've integrated. This demonstrates, and I get an answer mark at this stage. And then finally, my answer at the end gets my answer mark. Okay, well, I hope that exam question made sense and you were able to follow what I was doing, and then you was able to follow how to mark it, because that is now S1 finished and continuous random variables finished. At this point, you should do some independent study, work on continuous random variables, so do a mean, variance, median, and quartiles exercise. And then once you've done that and you feel confident, have a go at assessment 12, which is continuous random variables, mean, variance, median, and quartiles assessment. Okay, well, I hope you found this video useful. I hope you found all of the videos useful and that it's taken you through S1 and that you feel that it has prepared you for your S1 exam. Good luck.